Hello, and welcome to Apropos, a conversation between Clojure programmers that you can join in live. We're going to discuss a few Clojure news items and share our opinions on them. Then we'll jump into a REPL and code some exercises or do some demos. If you're joining us live, feel free to comment in the chat and we'll try to address the questions. So panelists today, we have Mike.
Hello.
We have Ray.
Hi.
And I am your humble introductor, Eric. Hello.
Not the introductor, introductor.
Introductor.
Okay.
And we're missing Mia today.
Yes.
She's got a fire somewhere.
In the object-oriented world, they call it the introduction manager factory.
Oh, right.
Yes. One of the Gang of Four patterns. Yeah.
The builder.
I thought I had forgotten about that kind of crap from half a decade ago.
Yeah.
Try to burn it out of my memory.
Yeah.
Okay, so that's not one of our topics. So why don't we go to one of our real topics? We can bash on other programming paradigms another day.
Indeed. Yeah.
So, Ray, you had a topic.
Yeah, it was about code quality. Something came up. I don't know where it came up on the stream or whatever. In life in general, of course, you're always thinking about this kind of stuff. So there are various ways of looking at code quality, and I think we can probably maybe take down one route, but there's or route, as I would say, but you would say route, whatever. We take one direction, and then we can see where it goes. But I was thinking about stuff like, when you're in a team, code quality can be just something as simple as having, like, making the code all look the same, or making the code layout the same, having a limit on the width of the code, something boring like that, some number like, okay, when are you going to go to, some people say 80, some people say 120. I mean, you can get into the spaces versus tabs argument, I think, almost there. When I was working another place, it was always like, everything has to be stopped at 80. And to me, I feel like that's crazy, but okay, people have their reasons, so they go with 80. And it means that you can kind of always look at the code and feel like it's consistent across the code base. Mm-hmm. Whereas often with code quality, on a team at least, you can almost tell who's written the code. And I think, now I don't really care whether I can tell that or not. I mean, that's sort of, I don't know why that's important really. But I think that the notion of being able to approach the code and look at the code in the same way is good with a team. And then you've got some tools to help you format that kind of stuff. Now that's a very low level of quality, I've got to say. I mean, in terms of like, what does it tell us about the quality of the software? Bugger all, basically.
It's the textual quality. Yeah.
Yeah, it just gives us a kind of like entry point into the code that makes it kind of accessible with that uniformity. And then there are other things, like there are tools that can like do linting, let's say, or so you can take out unused variables or take out and again, these are kind of automated tools that you can use to clean up the code automatically. And I think that's probably a bit closer to like having the machine help you with your code quality. And then the other aspect of it is like, well, doing reviews. How often should you review the code? And how should you do that code review, and what kind of things are you looking for there? So that's the kind of topic I was thinking around.
Okay.
So yeah. What do you guys do typically? When you're looking at code quality.
One thing I kind of feel, and I'm not completely sure about this, but it seems like in ClojureScript, there is more uniformity. In the sense that, for example, you don't normally have like extra white space between things, right? It all kind of just hooks together. So a lot of that decision has been made for you, and it seems to me that the major choice you're making textually is like where to put the line breaks and stuff like that. And it becomes more difficult to detect who wrote a bit of code just by looking at it textually. Of course, there could be like the choices of names that could like hint, clue you in on who came up with a name or not. But it feels to me that a lot of that, like a little bit of stress about, oh, is this formatted right or not, seems to me have gone away, and it's like the par edit and par infer kind of auto formatting of things just kind of makes it so that has gone away for me, at least.
Yeah. Yeah. So, I mean, when you were talking, I had a few things come to mind. The first is I kind of looked at like long lines. I look at them more like the same problem as having a long method, right? Like a long function. That if you have I don't know, I'm thinking in JavaScript because you tend to like chain stuff, you do x dot y dot z, and it gets pretty long. What the break at 80 does is it forces you to say, okay, I'm going to do this in 2 steps, and then you have to find a way to name it as a variable, name the intermediate value as a variable, and that actually helps read it, because you're not just reading this like long thing. You're reading, do this, which is half as long, and then do this, which is half as long. And it also prevents you from going too far indented with like nested ifs. You should start thinking, maybe there's some pattern here that I'm missing if I'm just indenting my ifs so much. So I do think of it more than just consistency. I think of it more like it's an artificial line. You draw the line somewhere, 80 or 120 or whatever. But when you draw that line, it forces you to, not nest too deeply and then not chain too deeply, I guess is what it is. Start thinking about readability of your code.
Yeah, and also if you don't put line breaks, like you could define an anonymous function and have it all right on one line there, right? I find that visually hard to parse. I can do it for very tiny ones, but I would prefer to use more vertical space at times and just put line breaks just to help you read it,
For sure.
Yeah, but shouldn't everything be less than 100 lines? And then you need the long...
Yeah.
It has to be less than 100 lines, and they cannot be more than 80 characters, because then you've got this rectangle and everything has to fit in.
It's weird, actually. I mean, I take your point, Eric, there, because I think sometimes it is a good habit to kind of see that break at 80 as a kind of way of reducing the amount of indentation you've got. There are certain forms where that's a bit annoying, with core async loops and stuff like this. You end up kind of slightly going over it, and it's not, it's a bit jarring. Then you go over that 80, and it's like, I'm going over it. But it's good to have a general discipline, I think. Yeah.
And like we don't have it so bad. Like, I'll do 2 space indents, right? So every time you nest, it's 2 spaces. But in JavaScript, people tend to do like 4. And so you just get, I don't know, much more indentation.
Yeah. Okay, so that's the formatting thing, because I think that's a good one for consistency, and I think you make a good point there about the fact that if you have some limit, then it forces you to think about the size of your functions, and I think that's probably a good discipline. Yeah. What about the other stuff where you want like some bit of software to help you? Does anyone use anything external, like because sometimes with cursive, for instance, it can highlight if you've got unused variables, which is quite nice.
Right. So like I've done that. I've done linting in other languages, and it really helped. I don't do it in Clojure. I've never done it. I've used Kibit like way back in the early days, and I didn't find that it was giving enough value. So like when I use it in JavaScript, the reason I use a linter in JavaScript is because the language is so big and I want to stay in a subset, right? And I want to make sure that I'm working within this well-defined place where I know that there's no gotchas, right? Or I understand the gotchas. But in Clojure, I don't feel like that is the problem, right? Like the stuff that Kibit was telling me was, oh, you only used the then branch of your if. Why not change it to an else? I mean, to a when,
for instance, yeah.
And I was like, yeah, that's cool, but it's not like it was less safe to use the if, right? It was things like that just got me like, yeah, that's great to know, but like, I don't know, I didn't need to be pointed out to me.
There's also, like, when you're writing code, there's like so many ways to skin this cat kind of problem, where you have like there's so many approaches that you could have taken to even a tiny little in the small thing, that to me, it's kind of like, just let that go and don't stress over it. Just, any one of those potential of 5 different variants is fine. I guess that when you said Kibit, it reminded me of like, oh, it might show you a simpler way to construct some answer to something.
I think in the early days, it can be quite handy, because if you don't know about that flavor of when rather than if, and then I think it's quite nice. But like you say, it's very basic.
Could it tell you how to do a reduce? If you have a recursive function, could it tell you like, oh, this is how you would write the reduce? And that is actually very useful, right?
Yeah.
And then it would show it to you, and you could say, oh, that is better. And then you just, click a button and it puts it in.
Yeah, I think that kind of refactoring is not available, is it?
There's things like you could filter identity, remove nil, filter sum. It's like there's so many different ways you could do these things, and like you just got to be able to read them all, because you'll find them in the wild. And
The other thing I was thinking about was sometimes these tools, what people do is, and I've had this discussion with developers over the years, is what some people say is these tools, they're kind of okay, and I think code formatting and those kind of things are, I think people can get behind that. But as soon as you start having these tools to say what you should do, I think people start thinking, well, are we relying on these as crutches? Are we going to rely on these software products as a kind of way to prove our quality out? There's a lot in the enterprise. There's a lot of these tools that look at your code and say, oh, you've got some complexity metric, and you've got some of this, and you've got some of that. None of these tools really exist for Clojure, as far as I know. What's that tool called?
Like cyclometric complexity and stuff.
Yeah, like McCabe's complexity metrics, and I think it's called NCube or something like this. They have this like big spider graph of like the things that you've got: technical debt there, you've got complexity, you've got coupledness, and all these kind of things.
I see those as like they're enterprise tools where managers, they want to micromanage. They want some metrics on how good their programmers are doing, and
more like how good they are. And that's the thing I find hard to judge on these tools. Yeah, I agree. Yeah.
And so, like, I mean, maybe you just have bad program. I don't know. I'm not going to judge, but like, I've never found them useful. It's like, is my code complex because it has a lot of nested loops? Is that what it's looking at? Like,
I think in general, yeah, it's looking at things like where you're saying, if I've got lots and lots and lots of like big long functions, and this function, that function, everything loops back to, especially it's very true in Java, where everything sort of depends on one object. And everything's like the spider object
statement.
You've got this big spider object in the middle of your whole object graph, and everything depends on it, and it's a kind of bad smell. But with functional programming, you don't get that so much,
right?
Especially not Clojure code,
Yeah, I guess we're kind of lucky in this language that it's arguably so simple that you can tweet, solutions to problems because it fits. And I would even go farther. That
who would do that?
Well, you can also even write code in your head. It's so simple. You can actually pull off a complex idea in your brain without even typing it, which I find amazing. You could actually structure something in your mind and then manage to spit it out afterwards, and it'll be close to correct.
These things all make me think like you're not going to refactor away this kind of complexity. right? Like this was the whole point of my talk in at the Conj a couple years ago, where I was talking about how everyone talks about code style and code quality and, you know, refactoring to clean up your code. But no one's talking about the content. They're talking about style and not content. They're talking about like how to name a function, but what is the function supposed to do? Like, how do you choose what functions you want? And I think that, I mean, you see this, I think even in like literature and stuff, for the longest time, it was all the talk was about style. And no one was talking about how to construct a story. Like how do you make compelling characters? Like they were just talking about like flowery language and stuff. And the other stuff was just thought of as like, well, that's just, there's no system to it. But like there is, right? There is a lot of thought behind how to make a good story. And I think that we don't have that in our industry. We've talked too much about code quality and not about like abstraction quality.
Like the superficial things.
I think the word quality is being hijacked basically by these tools. Like that's kind of like where I'm coming from as well, is that a lot of the focus on quality is surface level, and it's not truly thinking about, well, does this, I mean, because in the end, quality is a very, you know, in engineering sense, you want it to be, and I remember I've worked at Toyota for a long time, and one of the things there is you want good enough engineering, but not over engineering. And understanding what the difference between those two things is often a matter of like economics, or it's a matter of safety, or it's a matter of aesthetics. So it's very tricky to actually define that line between, you know, good enough quality and over engineering, where, you know, you're just putting too much effort into fixing a non-problem essentially. But I think if you really think about code quality, it's about how we speak to each other as human beings, how we write code that helps each other to discover what the other person meant. It's sort of the expressiveness of the code that is more important than, you know, does it do what it was meant to do? And is it very close to, in the code, describing what the kind of solution is to the business problem? I'd rather focus a bit more on that level of quality discussion rather than the kind of metric crap.
Yeah, that's really cool. I think that this like refactoring, like I like refactoring, I like the idea, I like the book, I like it all. But I mean, I kind of go into this in the talk that like refactoring can only clean up a mess. Like it can't, like it can clean up your room, but it can't tell you what you need to put in your room, right? Like if you have the wrong stuff in your room, it's just going to tidy the wrong stuff. And it comes from this imperative world where there's just like so many steps that you need to take to get to the answer. And it doesn't matter, like what matters is the order, but like how you group them together, and like you can name them separately. And so there's all these choices you can make about like, okay, pull this out into its own method and make this like be parameters to this thing. And like, so you can change it so that it does exactly the same steps, but in a, you know, organized in a different way.
Presumably it's organized differently because there's a pattern for a better way to do these things, which has more testability, or you know, it's got better less state or whatever, better names, or less dependencies on each other, and those kind of good things. These are all good things. But like you said, it kind of imperative, object-oriented things, you know.
And I think in functional we have this other, I guess, dimension that we can think about. Like we're talking about composing up operations on data. And so you have this, you have a choice of like, how do you represent it in data? And then what are the operations that need to be on there? And how do the operations compose with each other? And this is something that that I would like to develop as like a literature of functional programming. I'm talking more about this kind of quality instead of like style.
There is one superficial thing I kind of think about, which is the whole code golfing subject. And what I find is that this is just my observation or opinion on it is that you can, when I first write code, it's typically a mess, but it's also typically fairly verbose. It's using more words to say than what I need in order to say it. And then I find if you code golf it a little bit, it'll become actually more readable. And then you can take that too far, right? You can code golf it down to the point where it becomes less readable. And there's like some happy medium in there where it's like compressed a little bit, but not too much.
Right.
And that ultimately gets to this nice readability metric, if you will.
Sure. Yeah, but it's very hard to define, isn't it?
Yeah. Oh, you just know it when you know it, right? You're like, you code golf too much, and now it's too small, and it's too hard to read now. Yeah.
I do something. It's a habit I've got, which is a good habit, which is I'll clean up the white space of the code and line stuff up, and I find bugs when I do that.
Oh, okay.
Right. It's interesting. It just gives you like this level of detail. Yeah, like I'm looking at all these little details, and oh, whoa, that's weird. I didn't test that case, or you see stuff like, well, I do this way 3 times, and the 4th time it's a different way. Maybe that's wrong.
Maybe there's something about like beautiful code is closer to being correct, and if you have a mess, it's harder to see the bugs than a messy fragment of code. Yeah. But if it's nice and almost elegant, then you're like, I can see the bug now.
Exactly. There's a talk.
Either beautiful or ugly, yeah.
There's a talk, I think it's called Therapeutic Refactoring by Katrina Owen, and it's in Ruby, but she like zooms out the code so that she can see the shape of the code, and she uses that as a guide to how to refactor. That the shape, like if you got a big, like, let's say a case statement, right? You kind of want all the cases to be the same. You don't want some to be at one abstraction level, and so they're like really low level, and so it's this really big mess. And then some are just call one method here, and like no, they should all be calling a method if that's the level that they should be at. So
yeah, difficult to generalize in that way, isn't it? But you can get some rules of thumb. Yeah.
Yeah. It's just again, like it's so hard to define, but you can kind of use these different ways of seeing to help guide your intuition.
Yeah. Well, maybe we're kind of like bumping up against the time zone. Maybe or the time limit, but maybe we do like testing kind of stuff next week, or maybe we go on to the next topic now, and we
testing.
Well, next week we can talk about quality, because I think testability is part of quality, isn't it? If you can test things and how do you test things, then that's a kind of good subject I think we maybe just need a bit more time on.
Yeah, sure. So does that mean we're going into the REPL?
I don't know, do we have time for another topic, or are we
maybe?
Yeah, we could. Yeah.
I don't know. So, we started a bit late, so I don't know how I don't quite know how we're doing for time.
You know that topic, and you might have a sense.
Yeah. So I was just talking to some people today about their website, and they've got JavaScript on the website, and they wanted to know if there was if I had some good tips for converting their site over to using ClojureScript instead of JavaScript, but they're using jQuery, and they don't want a whole single-page application. They want to keep their HTML generated on the server, and then do the sprinkles thing where you make little things interactive. Like I don't hear people doing that anymore. I'm sure people are, but there's not a big buzz about it. So I wanted to get y'all's opinion on that.
So, and you were thinking just not using a React binding, basically just pure ClojureScript to, right. To be honest, even going back when I first learned about ClojureScript, I was kind of concerned that it might perchance have something that tied it to the web, because I wanted to do mobile apps in it, and I was hoping that this language was not hooked to the web, and I found that it wasn't. It's just a language.
Right.
Yeah.
So in that case, I guess if you want to write little bits of your logic or your implementation in ClojureScript, you could do that thing where you write it, and then you have you have externs so that those things are exported, and then you can call them from your JavaScript.
Right. Yeah, so that's what so I recommended a few things to them. One is that when I started using ClojureScript professionally before React was a thing, and we did a lot with jQuery, and because that's just what everybody used back then, unless it was Angular, but we didn't do Angular. And so we had a lot of good luck with that, right? And so yeah, my idea was you can call your JavaScript from your ClojureScript.
Yeah, just using interrupt.
Yeah, and you can do the opposite. And so I was like, you should find something with like really bad callback hell and use core async. So rewrite that middle
piece.
part, that piece in core async, and then export the function so that you can call it from JavaScript. And that might be the biggest bang for your buck.
Maybe the other question is like, I mean, to some extent, the question is, why do we want to use ClojureScript at all? You know, I mean, because we like it, I guess. But often on the web, the ClojureScript community, at least, is focusing on like the concept of an application rather than just the concept of like brevity or the concept of, you know, a more expressive language for a non-application environment. And that seems to be where most of the focus is. But you're right. I mean, I guess the question is, if you're a team that is used to JavaScript, where are the real? I mean, I think your point about like this callback hell is a good one. But is that very common in jQuery? Because when I was doing JavaScript in the good old days, it was like, you know, where's Backbone and Ember and, you know, those kind of application frameworks. And then ClojureScript made a lot of sense because those frameworks were horrible. But jQuery is quite small, isn't it? It's just focusing on DOM stuff. Maybe it's a bit of Ajax and, you know.
I know, like, I mean, this might not be a huge benefit, but when I do have to write JavaScript, I just feel like this is a lot of code to do very little. Right? Yeah. Where I know in ClojureScript it would be like 3 lines, and then in JavaScript it's like 20 lines.
Yeah.
And it's not everything, but very, like, you know, the longer the JavaScript code gets, the more I'm like, it's doing like less and less. It doesn't scale well.
Okay. Yeah.
Every line now does less than a line did before. And,
That's interesting. Yeah.
So, you know, when it's a small thing, I'm like happy to do it in JavaScript. And then once it gets to about 50, 60 lines, I'm like, I wish I had done this in ClojureScript. There is that barrier of like having to set up the build step and, you know.
To this day, I have not written anything in JavaScript.
Never?
I think I'm probably a bad example, but for me, the answer is I don't know this language that you're talking about. And I write stuff. I learned Clojure. I came from a Java background and I learned Clojure. And that was my gateway into being able to write front end things using ClojureScript. And I never did learn JavaScript. I mean, of course, I can read the things that look like Java, right? The C-based stuff.
But all the gotchas.
But all the prototype stuff and all that weird crap, I never learned that. And I've never actually written a large app in Anger that way, you know.
You know, I always wonder, like, what is the thing? Because people ask me this all the time. Like, what is it that makes it nicer? Like, can I just do, you know, I've got functions, I've got some data structures. Now there's destructuring and stuff. And they're like, what is it? And I think that there's just a touch of design that JavaScript never got. And just like a thoughtfulness that compounds. So stuff like the fact that you're not going to get a null pointer exception calling any of your functions on a null, right?
Okay, yeah.
So like null is a seek. So you just use it like a seek, and it's just the empty seek, right? And things like that just really add up, where you're not null checking all the time, and you don't have this other case that you have to switch on all the time. You know, the little bit of love in the standard library, like being able to take a string and just get all the characters as a sequence, you know. Whereas in JavaScript, that's a for loop. Yeah.
Yeah.
So
Then
do
you have
you-
this like. No, sorry, go on, Mike.
Well, I was just wondering, when you're programming in JavaScript, do you run into the insane semantics that it has, like the what things? Do those happen enough to bother you, or is it just like, if you know that language, then you're
Occasionally,
a master of it, and it doesn't bother you? And then it becomes a question like, why should I use something like ClojureScript? I can readily write stuff in JavaScript. And
I think the whats you learn to
learn them, yeah.
not encounter them, you know. You just have like this very safe subset of JavaScript that you're familiar with and you feel comfortable with. And then it's like occasionally like you'll step out and you'll use a function you're not used to, and like, oh, it has a second parameter that does this, you know, like the parse int takes a second parameter of the base, right? And it defaults to 2, but then if you use something like for each or each, which passes in the index as the second parameter, like you think I can, it's and you're like, well, what? Why is it not working? I did it on one and it worked, and I did it on a map. I did a map and it doesn't work.
Yeah. But so those things you just learn and they become part of. It reminds me of C++. You stay within a subset of the language, and you're good. You learn it and you stay there.
And that's actually in a lot of linters. It's like, oh, you used parseInt without the second parameter, or you passed it to a higher order function. You shouldn't do that. You should wrap it in a thing that passes a 2, or it's not a 2, a 10. Yeah.
Yeah.
So no.
I think maybe it comes to the point of like wondering, because I know that there were attempts, weren't there, in the early days, DOMI or something, to wrap jQuery. Was that DOMI?
Yeah. DOMI doesn't wrap jQuery.
Oh,
DOMI
no, it replaces jQuery.
Yeah, it replaces. Like, it does a lot of the selection and the DOM manipulation stuff. Yeah.
The other question I had for you as well, I mean, again, I'm not a web expert by any means. I play with it a little bit, dabble with it. But I remember with HTML5 that all the browsers were meant to, you look at this like the portability of various methods and functions and HTML type things, and people, who have got more flavor of this than I have, they say, oh, well, now jQuery is a bit less useful because the browsers are, you can express more code in CSS and HTML, and so maybe jQuery itself is kind of waning, not because it's a bad thing necessarily, but because the fundamentals are improving underneath it,
And then there's also the thing that people are writing like when jQuery first came out, people weren't doing much JavaScript. And so they had this HTML that they didn't have the right to modify. And so they had to do these really nasty selectors to like get that one link on the page to change it. And now people are writing their HTML with the knowledge that they will soon be JavaScripting it. And so they put a tag, they put an ID or a class on that they can just easily pick out. And so a lot of those like selector gymnastics that you do in jQuery were merely because of the time, like you were adding it way after the fact. So yeah, it's less useful in both the fact that browsers are better and we're writing different HTML now.
I guess if you have like a team that has a mixture of people who know JavaScript, then you're toying around with ClojureScript. To me, the hugest difference is the immutability in ClojureScript. And that, you can't fake that. And it's like it's a cultural thing. The whole language has to start from there, from the bottom up, and you can't take another language and put that under the bottom of it. It has to be there from the beginning, right?
Right, and even doing stuff like so Backbone is this whole framework. That just managed. It just had a model. It just had a way of doing like set on a piece of state, and then you could observe it. So you would get you would like subscribe to changes to particular bits of the state, and so that was a way of like having reactive view changes based on the state changing. But like an atom does the same thing, right? And so if you just put all your state in an atom, you're like past where Backbone is, because Backbone still required you to have the discipline of, you know, only calling set state, don't call.
And wasn't there a cottage industry? Wasn't there a cottage industry around that as well, with babysitter and all these other things that looked after memories and stuff like this? You know? Yeah. Spine, and there was a thorax. You know, they went from Backbone and they built out the skeleton. It was quite funny. There was thorax. Thorax did exist. You know, I'm not joking. Oh man,
yeah, that's all crazy.
Yeah,
that's all crazy. And so, like, you could do. Go ahead.
I was just saying, that's the other thing about, to Mike's point about like immutability. I mean, because actually, of course, there is immutable.js, and there are a whole. I mean, you know,
but that's not enough, though, right?
No. But it's interesting how the React team and that kind of team are looking at functional programming and kind of trying to offer the JavaScript developers those features. What's unfortunate about it, though, is, like you say, is that, well, you've got a mixed team of people with different experiences, and the language defaults aren't supporting that choice. You have to opt into it big time, you know, because it's not idiomatic even. It's nowhere near idiomatic. So you're really forcing a different choice on a language.
You still have this problem of like null checks, right?
Yeah, sure.
You still can't call like .map on the thing that you get. And I don't know. I feel like it's cool, but then the code doesn't really shrink. I don't find it to be that. I've used Immutable.js and it's got that problem.
Well, again, it's more of a kind of safety thing than it reduces the expressivity,
right?
Kind of like weirdly, but it does give you those kind of like more safe ways of traversing the collections and things like that. And you know, the fact that you can, you know, like we have these kind of like functions that iterate over things or react on things. You can do that more straightforwardly with immutable.js and more securely, more safely, but at the cost of, you have to write code that's completely different. Yeah. There's another one called Ramda, which is another kind of
I've heard of it, yeah.
Yeah, another one of my colleagues at the old place, they used to use Ramda, swore by it. It was really nice, you know. But again, it's always a kind of like a flavor of functional programming that, you know, three developers have different ideas. One wants immutable.js, the other wants Ramda, the other guy wants what's the most common FP one, whatever that's called.
Underscore.
That's underscore. Well, even underscore and Lodash are fighting, you know. So yeah, those kind of things are, you know, that's the problem with JavaScript as well, is that there is no. It's a very vibrant. It's a problem and it's a benefit. It's a very vibrant ecosystem. But there's a lot of fragmentation as well. Yeah. So I don't know a great answer, unfortunately.
Yeah.
Well, people did people use ClojureScript before Ohm, before React?
I used it. I used it with jQuery, and it was okay. I mean, I just used all the tricks I knew from the JavaScript world. I just did them with a better language. You know, I was doing all this stuff with, you know, modeling stuff as data structures and stuff, and then when I needed to hit the DOM, you just do some jQuery stuff.
Yeah, I did the same thing with, before React Native, and it was a bag of hurt back then. Like ClojureScript made it nice, but then you're dealing with the mutable world that is the iOS SDK. And
well, I remember still being frustrated because there were things that it's like, this should be easy. Like I know what needs to change, but I have to keep like a tentacle on every single DOM element that I might need to change so that I can update its attributes and stuff. And I was just getting really frustrated with the spaghetti of that. And then David Nolan gave this one macro. He was like, this is the minimum amount of code you need to get React working with our immutable data structures so that you get the identity, you know,
comparison thing.
Optimization. Yeah, identity comparison optimization. And so I started using that macro. It was like this big. It was tiny.
What's the genesis of Ohm? Yeah.
It didn't do any of it just did a render, right? But it was And that's all I needed. And I was like, oh my God, I love web programming again, because this thing that should have been easy is now just how I think it should be. I just have a big tree of state and I just traverse it and render it out. And I felt really good.
Yeah, because he did a thing called MoreA, I think it was called, or something like that. MoreA, which is a kind of precursor to Immutable.js.
Oh,
JavaScript,
yeah,
which
MoreA, yeah.
ported over the persistent collections to
He did.
to ClojureScript.
Tried to give it a JavaScripty kind of API so that people could do the method calls that they were used to.
Yeah.
Yeah. That was cool. I don't like I think that people find that they're useful in like these little contexts when they're programming in JavaScript, but not something to just kind of go whole hog on.
Well, what's interesting though is like MoreA and Immutable.js are, I think, essentially the same thing, but Immutable.js gets huge pickup, and it shows the power of marketing, and the brand. So, but let's not go down that route.
Yeah.
Because that's another bag of worms.
Yes. Okay, I think we exhausted this topic. I feel pretty good about it.
Cool.
Cool. Let me ask if anyone does know of like what is the current state of the art of doing non-React ClojureScript. So just like jQuery style selectors and modifying the click handlers and stuff. Let me know. Shoot me a message on Twitter. And I'd love to hear about that.
Cool.
So is it time to switch?
I think so.
Okay. Well, we're about to switch over to the REPL. If you're listening on the audio version, we're going to end it here. And you can watch the REPL coding on YouTube if you missed that. So let's switch to our REPL.
All right.
Are you in charge of that, Mike?
Am I in charge of that?
I mean, clicking it.
Is anybody in charge here?
Oh, that. I didn't understand what you meant. Okay. Yeah, let me, I think I am. I have the power. Let's see. Is that it now?
No.
No? Okay, let me click again. What is the trick?
Must be in a white box or something.
There we go. I think it worked. We're
just kind of slow. Yeah. Good.
Yeah.
Oh, okay.
Yeah, I have a white box around it.
Yeah.
The REPL is highlighted.
But
so we have this problem. It is about finding the 10,001st prime.
Oh God. Okay.
It's from Project Euler.
All right.
This one was one of the ones I still remember when I was learning Clojure like 10 years ago. That I was like, oh, sieve of Aristophanes.
Yeah, you can't say that word. Yeah.
And I just wrote it with a filter, and I got boom. It didn't. It like either ran forever. I got an exception, like out of memory. I don't know. I don't remember what it was. Yeah, but I was like, oh, the naive answer is not good enough because it got like the first 60, 70 primes, and then it died. And so that's what really made me appreciate these problems, that they're like toy problems. They're like Fibonacci style problems where it's like, oh, I can solve this in 5 lines of code. But then the problem is so big, like the 10,001st prime.
The approach is important. Yeah.
Yeah. Then now you have to think about memory and optimization. It becomes a real world problem because of that.
That's what all the Euler problems are like that, right? They sucker you into this simple thing, and then
exactly. They're like, you can do the first few primes easy, and then So, who wants to tackle this?
I have not actually reached
Why does the sieve not work? Let's see. I want to talk about that before.
Do you want to guess? Because I remember now.
Is it quadratic in complexity or something? Is it? Let's see. How does the sieve work again? You make an array, right? So you have to have an array that's big enough to hold 10,001. I would imagine, to do the sieve.
No. So
No?
that's a very imperative kind of
imperative sieve. Okay.
approach to it.
Okay,
So what you
yeah.
would do is you make all the integers, right, and then you filter them. So you filter them by you take off
By
the
even
one,
or whatever. Yeah.
take off the 0 and the 1, right? Because they're not prime.
Okay.
And then you say, and the 2 is prime. And so then you divide all of them by 2, or not divide. You filter them out by the ones that are
The multiples of 2. Yeah.
yes.
Okay.
And so then you have the next one, which is 3, and so you filter them all by 3. So you've got this like chain of filters.
Oh, interesting. Okay.
And what happened to me was the filters got so deep that I was hitting a Stack Overflow.
Oh, okay.
Because it would filter
it's like a
and
recursive.
then
Exactly. Interesting. That is cool though.
Because 10,000 is too big.
So in the imperative one where you just make the array and you start just marking things off in that array, you never do have a stack that you build up in your language, I guess.
Right.
But I bet the filter one looks elegant, right? It's kind of or it's very
even like
intellectually intriguing looking. Yeah.
Exactly. Now,
Is there a problem with the size of this terminal, by the way?
yeah. Could you increase the font size? Who's got it running?
Hold on, I've got it running on another machine. Hold on, I'll be back.
Oh, it's going to the Wizard of the Oz room. Yeah.
Nice.
The man behind the curtain. Yeah.
So I would definitely start with a range. And I would start with
okay.
2.
Yeah.
Let's see. That's def ints. Uh-oh.
So Ray doesn't know when to stop making it larger.
Whoa.
That looks good, actually. Yeah.
That stop. Oh, perfect. Don't move. Oh. Okay.
Okay, so you're defining
integers there.
All right. So
now you want to take the first one because you know it's prime, and filter for multiples of it, right?
Okay.
So let's do something like multiple of.
All right.
So then it'll be let's call it the divisor.
Yes.
And the number. And then we're going to do mod num divisor, if that's equal to 0, right?
Yes, I like that.
That look right?
Test it real quick. Just test it in your REPL to make sure.
Multiple of 2, 4, true, 5, oops, false. Looks good. Okay, so then we want to do So how would you do this sieve?
So you would filter your integers and filter out multiples of 2.
So
that was your first.
Yeah.
Okay. And that would give you a new subsequence or whatever.
Right. So that's going to be all the non-even numbers starting with, well, see, but we want to keep 2, right? So that's not going to work. I remember there was.
Do you do the rest instead of?
Yeah, I think I did it recursively. Like I did it.
Like if it's equal to 2, do this. Otherwise, do that.
It was take the first, right? Get the first one,
yeah, okay. Yeah.
And then const that onto the filter of the rest.
Oh, right? Okay. Yeah. So, and is it like a lazy seek kind of thing, maybe, or?
Yeah. So let's say maining, and so they would do first and rest. And we know there's no base case here. It's infinite, right? So I'm not even going to do it. It would be const. Yeah, let's do lazy. it up here.
Put it outside there.
Easy
Okay.
seek. Const f
And
filter remove multiple of f percent rest. No, now then we have to call remaining on that so that it's recursive.
Sieve.
Sorry, you're right. Sieve. Okay, oops. Oh, I didn't have a thing. Remain. Okay.
It's interesting looking.
This is not going to. No, it's going to work. Okay, that's fine. So let's see if I call sieve on
your integers, maybe.
Yeah, we can try it. I want to try it on a shorter one first.
Yeah.
So let's do
okay.
Take 10 integers.
Okay.
Divide by 0.
Yeah, maybe do the rest of the integers or make whole numbers or something like that.
Well, what is integers?
Because it starts with 0, right?
Does it? I thought I did range 2.
Oh. Yeah, but you should want 1, 2, don't you?
You wanted to start at 2? Maybe
I wanted to start at 2.
Iterate inc 2.
Yeah, 2. Oh, you need 2 to end then, don't you?
Yeah.
Isn't that what range 2 does? Oh, it does range.
That's the endpoint. Right. Yeah. You want to start, so iterate inc 2. Yeah.
Yeah. Okay. Okay, so that's the integers.
Okay.
Now the sieve. There you go.
It's taken a while.
Taken a while.
It's taken a little while. Oh.
And we're not going to be able to know
why. Okay, so there's a sieve. Oh, I need to do multiple of.
Mm-hmm.
Oh, we don't have. I thought this was read line.
It is.
I'm looking for multiple of.
Oh, you're like doing Control R right now?
Yeah.
Huh. Bruce,
there it is.
Oh, there it is.
And then def integers. Iterate inc 2. All right.
Okay.
Now the sieve. So what did I do wrong?
Okay, let's see.
Because that shouldn't break anything, just 10.
Remove the multiples of rest. So you have rest in there. So it should get like a smaller problem each time.
Mm-hmm.
I'm getting the first and the rest from remaining.
Maybe when you
exhaust it. I do because I do have a base case in this case.
Nil at the end?
Yeah.
When rest is empty or remaining's empty.
When empty, when. If empty, remaining. Right. I was thinking of the infinite case.
Okay.
Obviously. Okay. There we go. Let's try again. Where is it? There we go. So are those the primes?
They look very prime to me. Yeah.
They look like the primes. Yeah. Can we try a bigger case? All the primes to 100. Ooh. See, it works, right?
Looks good. Yeah.
Now, what is the 10,000 first?
Yeah.
And I just want yeah.
Or you could do like time on, you could like take the.
Well, I think this is a correct answer. Just
it worked. Oh my God. Maybe Clojure is faster than it was. I mean, maybe I hadn't tried it. Let's see. Oh, there we go. Stack Overflow.
Okay.
Okay.
So that's what happened to me and this was 10 years ago, so I probably had like a quarter of the RAM that I
Okay.
have now.
And this is because Civ is calling itself.
It's because it's calling a filter. It's calling a filter, which is on a filter, which is on a filter.
But the other thing here is, someone's saying in the chat there actually, is that that's the first 10,001 numbers,
you're right,
but not the 10,001st prime.
That is why it worked. That is why it worked. Okay, so let's do nth on it.
Yeah.
Okay. Yeah.
Nth 10,001. Yeah. And bam.
And you'll get a Stack Overflow there probably.
It'll blow up straight away. Yeah.
ECC. Oh, is it the wrong order?
The wrong order. Yeah. Yes.
I get that wrong all the time too.
Yeah.
All right.
So obviously.
Wait, 10,001.
Yeah.
Ready?
Yeah. Bam.
Oh.
Okay.
Thank you, chat.
So I still don't. I still don't understand the Stack Overflow. So what is in the stack? Like,
because it's doing this. It's doing remove. I'm just going to put an F, and then that is on a remove F, and that is on a remove F, and that is on a remove F. So each, as you get deeper, the number of removes is growing.
Okay.
And so each one is adding to the stack.
Okay.
So I was thinking maybe, since I did this 10 years ago, that was way before transducers, maybe we can figure out, this looks like a transducer to me.
Maybe, yeah.
It might not be that efficient because you're just chaining a million, 10,001 transducers together. But can we do that?
So
there's the code again. Remove can do transducers, right?
That's a good question. Yeah, if you just pass the
looks like it's just got the pred. Yeah. So
yeah, if you say remove nil, what do you get back? It probably is a transducer. Yeah.
I do remove multiple of
percent.
2%.
So that's a little transducer. Okay.
Yeah.
Call that J.
All right.
And then how would I get a list? Is that educe? What is that called?
Or there's eduction. But
what is it?
Doc
how do you?
eduction.
What's that?
Doc eduction, I think.
Well, eduction will give you a list. Well, it will give you an eduction. That's a nice circular answer, but
so can I apply this to a range, and get a seek out?
Can you apply J to a range? Is that what you're asking? Or
yeah.
Okay. Oh, so you could do sequence.
That's what I want.
Sequence of that.
Sequence takes a transform and a collection. Okay.
Yeah.
So I just want to do sequence of J on take 10 integers.
Okay.
Okay. Just just little pieces
works.
here.
Yeah.
And how do I compose these up in this way on our? You can't just cons onto the front of a transducer pipeline, right?
Just enter on the pipeline.
So let's say instead of calling, can we do sequence remove? Wait, I want that in there. tough. Oh, I can't see the friends matching anymore. Oh, I see. You have to type them. Does that make sense? Is sequence lazy? Is this going to blow up?
Sequence does return, I think, a lazy sequence.
So we're doing remove, and rest is going to be, yeah, okay, let's try it. Well, worked. Let's try it. Oh, Bruce. Okay. Well, might take a while.
Looks like it might work. Would Stack Overflow a lot sooner, wouldn't it?
Nice.
I think that it is breaking the whole point of transducers, though, because we're conning on to, like we're just using it once and then making a sequence out of it instantly. So is it really gaining anything besides the, I guess the fact that it hasn't Stack Overflowed yet? That's pretty important.
Well, it means that you don't need to write.
Then it did. It just took longer to Stack Overflow.
Yeah, you can go.
All right. So then the other thing I thought about is to make it a stateful transducer.
So why do you think it just so I don't know if I get this. Why do you think it took longer to Stack Overflow than the first one?
It's less efficient to make a transducer, run it over a sequence, make a new sequence out of it, and then recurse to make a new one that does the same thing, right? So you're not just doing the simple thing that remove does of just destructuring a list, right? Taking the first thing off. It's
But remove is still there. So yeah, I don't know if I get it.
But it's the transducer remove.
Yeah, it's like it didn't really buy you anything. It's just
okay, yes.
It's the same. It's the same thing in the end, just kind of like a more expensive form of it.
Right.
Yeah.
Okay, so if we use a transducer, a stateful transducer, and I'm not good at transducer, so this is going to be hard for me. Maybe someone else. Are y'all good at transducers?
So this whole thing, it reminds me, there was I took the code for treeseek, which is it's a lazy seek based approach, and I managed to turn that into basically like a transducer solution, but the answer was big and complex, and much more than we could do here, where you're just sitting there messing around with REPL. And it kind of scares me. I wonder if this is the same kind of thing where, not trying to be negative, I'm just wondering, can you easily turn this into a transducer? And
yeah, it doesn't seem like it.
Is it really, what's the benefit of doing it in a transducer?
You might be able to do it lazily really fast without creating all these intermediate remove chains. Okay, look, I'm going to try to do this.
Okay.
In the classical way is it doesn't work well with recursive definition, so you turn it into a tail recursive definition.
Okay, yeah.
If this is empty, just stop.
Okay. And the accumulator is going to be the accumulated primes that you've accumulated so far?
Yeah, except I want them to be in a set so that I can use them really fast. So
yeah, they don't have to be ordered. We could sort them afterwards.
Yeah, so let me do S, and then this is going to be the list of them. I'm going to return the list.
You can have an ordered set.
I still want it to be lazy.
Yeah, okay.
Right, so How would I do this? I mean, I'm thinking in a mutable way now. Oh, my brain is not working right. I'm in a fog right now.
Yeah.
Do you have any ideas? So look, let's say I get the first and rest out of remaining.
Okay.
And then I'm going to check it. If something contains that, then I just want to recurse on the rest. Right? And then otherwise, I'm going to const f on the recurse. But I can't recur here. So I have to call it myself again. Right? And so I can make this lazy. So it'll be okay.
What's the L doing there? So,
Right. And so that should be
Just the empty
list.
right, yeah.
Okay.
And then this needs to be, oops, oh, what did I do? Get up to that line. There we go. So this should be the accumulator. So I need to, the accumulator is, that's there, it's passed by itself. And here the accumulator is cond, okay, right. I'm adding to the accumulator.
And the accumulator is a set in this case. Yeah, it's probably because it's inside that lazy seek macro.
Oh, you're right. So I got a lazy seek around here. Lazy seek. That's fine. It's just a little less.
Move it down in there.
A little less lazy. Okay, so let's test it on our easy case. Oh wait, but it needs an empty set.
An empty set to start it. Okay.
Whoa!
Quite.
It didn't work.
It's not doing anything, is it?
It's not doing
you
anything.
haven't got the you haven't got the multiple thing in there, have you?
If it contains,
maybe you have to prime it with a singleton set of 2 instead of the empty set.
Well, then the first one should not contain.
Okay, the first one should not contain.
Should
all right.
drop down here.
All right.
And
then
put
it into the set. Okay.
It puts it in here.
But you're just putting all the numbers in, aren't you? You're not actually doing anything else. You're not actually testing for the primes at this point, are you? Or is that deliberate?
No, because then, oh, it's not contains. Oh,
It's,
right. Yes, I see. I'm dumb. Okay, so it's if it's divisible by any of them.
Mm-hmm.
So then, oh man, I haven't done something like this in a while. Multiple. Multiple of f. No. F is a multiple of anything in there. So what is that? Sum?
Yeah.
Some
predicate.
Multiple of percent f on ac.
Yeah.
Okay, so now I'm iterating, so I might as well build up the list at this point. Let's see. There we go.
All right.
Yeah.
That looks good. Okay, so are we ready to do it on everything?
Do 200. Just
so are you thinking this might be a little better because it's got a recur?
Because it's not building up.
Like when that recur happens, it breaks the stack.
Yeah, it's skipping all the ones quickly that are multiples of one of the primes.
Mm-hmm.
And then the other case is not adding to the recursion, right? It's not adding to the stack because it's lazy.
Mm-hmm. Oh, okay. Yeah.
Does that make sense?
Yeah.
Not adding to the stack because it's lazy. Okay. Do you want me to do 200? I'll do 1,000.
No, I'm joking. Yeah.
Oops. All right, I need to add the thing.
The empty set.
Okay. So what is our big test? Nth civ
set.
Integers.
10,001. Yeah.
Whoa. It's still printing from before. Okay, it's running.
It's off and running.
Dun, 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 dun.
Do you think that printing was the previous output? I think we've seen Rebel readline
Seen
do
that
weird
happen
stuff.
before.
Yeah.
Like delayed printing.
Oh!
To be honest, I'm surprised. That's pretty cool.
Yeah.
Yay! Now let me. Oh yeah.
Okay.
Let me look at the. Let me look at the code again.
Yeah. And admire it. And see why does it work.
Yeah.
Why does this work? Now I'm thinking if we put them into a vector, because we've calculated them, they don't need to be lazy anymore, right? Does that make sense, or is that wrong? No, we can't put them into a vector. Has to be. We could add them to the end of something, but then it's not a seek anymore.
And maybe it just doesn't build up the stack anymore at all, if you just closely look at the way it's structured.
Yeah.
Oh, it's nice that it can happen.
we check
It's a shame we can't explain it.
No, I mean, to me, this makes sense. It's just, it's not as elegant, right? The remove was much better. This one is just, what it's doing is it's basically reproducing the remove in that if statement, the if sum, but it's doing it like once instead of remove, one remove for each number.
Mm-hmm.
It's using the fact that they're now in a set and iterating the set. Right.
Yeah.
So if you wrote a, well, maybe if you wrote a remove that was lazy, I don't know. I'm just thinking maybe you could do it by using the fact that with lazy seeks, you're not actually adding to the stack.
By the way, just a quick question on sum. Will sum always, does sum run across the whole gamut, or is it just stop? Does it stop when it's reached the first thing that fails?
It should short circuit, right? Let's see.
And I think it might actually be more efficient to do it as a vector instead of a set, because the vector is going to be in the right order, in the order of smallest to largest.
Okay.
And so then it's going to run through them in that order.
Because what would you gain from having a set actually? Because it's
right. I was just thinking. Yeah. See, it was much faster.
Well, much faster.
Yeah.
Because 2 is going to get rid of half of them right away, right? And then the 3 is going to get rid of a third of them. And so if you're testing like 7,900, like it's not going to help.
Yes.
So there you go. There you go. Much faster to use a vector.
Yeah, much faster.
Yeah.
Okay. There you go.
Right. Well, that's good.
Yeah, we're going kind of long.
Yeah, this is the longest ever. Yeah.
Oh, yeah.
Normally we get Mia to stop us and say, "Well, I'm off."
Yeah, she has to run to an emergency. Yeah.
That's a good thing. It's good. Okay. Well, I've got to go anyway, guys.
Yep. I need to run as well.
Yeah.
All right.
Cool.
Later on.
It's been good.
Bye.
Cheers, guys. Bye.
See you.